YouTube. Today we are going to be talking about VLANs and what they are, what they do, and how we utilize them in a network and how to configure them as well. But before we get into that, I want to talk about an important topic and subject before we get into VLANs. You must understand what a broadcast is and a broadcast domain for you to properly understand what a VLAN is. So, what is a broadcast? A broadcast is a message that is sent to every device in a network segment. Instead of targeting one specific device, it is sent to everyone, and whoever needs it responds. This is how devices discover things like IP addresses and MAC addresses. Why broadcasts exist? They allow devices to learn about their environment without having prior knowledge of the network. I'll say an example of this is in the layer 2 environment or in a switch. You have multiple devices plugged in. All of them belong to the same broadcast domain without utilizing VLANs. So without VLANs, they all belong to the same broadcast domain. So as you guys know, a switch has anywhere from 24 to 48 ports. It's meant for a large amount of users to connect to. So in that environment, all these devices could communicate with each other. They send constant broadcasts, so to be able to reach each other and discover each other. The problem with a large broadcast domain, the more devices that get added, the more the broadcast domain grows. That means devices hearing more broadcasts that they don't care about. This pretty much wastes bandwidth and processing power on the switch and makes troubleshooting a lot harder. So the reason why we have VLANs is to solve that issue right there. VLANs exist to solve that problem and logically segment these broadcast domains into separate individual broadcast domains. And one thing you have to think about within utilizing VLANs, or one thing to understand about VLANs, is when you have, say, multiple departments. You have, let me give the example of two different departments. You have your security team and you have your regular users. I think it's important for the security team to always, be up and running and online in order to be able to manage the end users or other teams as well. So if you think about it from that standpoint, when you break down the traffic between the two, there is less instances for one to be down longer than necessary. Say for instance, end user traffic ended up going down due to some networking issue or whatever. It won't affect the security team's traffic at all because it's on a separate broadcast domain. So therefore, it's better for security, it's better for scalability and troubleshooting as well. Makes things easier and less hectic when it comes to that standpoint. Another thing to understand is broadcasts stay inside their own VLAN. If a broadcast is sent in VLAN 10, only devices, like VLAN 10 being a VLAN that you created to separate the traffic. If a broadcast is sent in VLAN 10, only devices in VLAN 10 will receive it. Devices in other VLANs never see that broadcast. And that's pretty much how the VLANs isolate traffic. The only way for VLANs to communicate outside of its broadcast domain is through the use of routing. And that is a topic that we'll cover in a later video. But for now, let's stick on the topic of VLANs. And as you guys know, we talked about access ports and trunk ports in the prior video. Access ports and trunk ports are very important when it comes to VLANs. For instance, access ports carry one VLAN in particular. They're assigned to end users, and trunk ports carry traffic for multiple VLANs. That is the essential function for them, and they utilize tagging, VLAN tagging, in order to identify identify or tag the traffic across, so the other end could know which VLAN the traffic is coming from. The next thing I want to go into, and I'll actually pull up this lab to give you more of a visual representation of what I'm talking about. Okay, one moment. So this is the lab created to be able to explain this topic a little bit more in depth. And as you guys can see right here, I have a switch with about 12 PCs connected. And as you guys know, natively, these guys, or naturally by default, these guys are all in the same broadcast domain. I have not configured any VLANs as of yet. I've configured the VLANs, but I've not assigned any of these PCs to any VLANs or created access ports, as you guys know. So these are all default in the same VLAN or the same broadcast domain. So as you guys remember from the previous video, I talked about the default VLAN being VLAN 1. So let's go in and show you guys exactly what I mean by that. Let me label this right here. So this is all in the same broadcast domain. So by default, they're all in the same broadcast domain. Let me show you the VLANs on here. So as you guys can see right here, I've created 4 different VLANs. VLAN 10 for IT, 20 for HR, 30 for security, and 40 for management. You see how I've named them and categorized them accordingly? It's in a network environment or enterprise environment, you'll see similar naming conventions. It might be slightly different depending on the organization, but this is essentially what we'll do. We'll separate out the VLANs and assign ports or assign end users to the VLANs. So as you guys remember what I said, by default, all the ports are in VLAN 1. So these essentially could all communicate with one another in the same broadcast domain. Once you separate these out and start adding them to the ports, they could no longer be able to communicate with one another. So let me give you an example here. I've configured each of these PCs with their own IP address and default gateway. As you guys can see up here, this network, it's a /24, so it has 256 IPs, but 254 usable hosts that you could assign. But the thing is, with a /24, it can be broken down several ways. It can be broken down from into 2/25s, 4/26s, 8/27s, 16/28s, 32/29s, and about 64/30s. So the way we're going to break down this /24 is we're going to break it down into 4/26s in order to be able to separate the traffic out for each of these users. So each of these VLANs are going to have a /26, which is about 64 IPs, one for the network, one for the broadcast, and 62 usable IPs that you can assign. So as you guys see here, we only have 3 PCs, but we can extend it and add about 62 to each of these. So I've configured the IP addresses accordingly to that IP scheme. So as you guys can see right here, I created a script, and this is what I've manually configured so far onto these devices right here. So as you can see, I have VLAN 10 right here with 3 PCs. So PCs 1, PC 2, PC 3 are on VLAN 10, and they have the IP addresses in the range of 192.168.1.1 or 1.2 all the way through 4, and their default gateway is 192.168.1.1. I'll go a lot more into depth about IP, about subnetting, and all this information right here in a later video. But for now, just understand that these are the configurations for these PCs. These are all set. So for now, let's ping to show you guys that these are able to communicate by default. So let's ping from PC1 to PC12 to give you that example. And PC12's IP is 192.168.1.196. So let's ping that. 192.168.1.196. Believe this. I think it might be okay. Yep, that's correct. 196. Oh yeah, I'm not. Yeah, 196 is right here. So as you guys can see, the ping is working. It's continuous. So now let's assign these VLANs, or assign these ports into the VLANs, and you'll see exactly what happens afterwards. I already created the script right here, and I will pretty much copy and paste it into the switch. But before I do that, let me explain this script right here. So I've went into global configuration mode with this command, conft, as you guys remember from the first video. Then I went into the interface range of E0/0, E0/1, E0/2. So with this command interface range right here, you are able to enter the range of interfaces that you state after the command. So I'm going into E00, E01, and E02. And from there, I have access to configure all 3 of these ports that I add. You can do as many as you want. I'm not sure if Cisco has a limit on the amount of interfaces you're allowed to configure at once, but as long as you are able to configure them with, I guess, a configuration that works for all of them, then this range could take as many. I'm not sure what the limit is, but you probably have to Google that real quick. I've created each of these ports right here, this range of ports, into access ports, switchboard mode access, and I assigned VLAN 10 since that is the way that this topology or this design is going to be configured. So all 3 of these PCs right here, VLAN 10, these 3 are going to be VLAN 20, these 3 are going to be VLAN 30, and these 3 are going to be VLAN 40. And as you can see right here, that's how I have it configured based on these interfaces up here on the switch. So all of these commands right here are going to go onto the switch 1. So from here, I could just copy and paste it into the switch. Trust me, it takes a lot of time to be able to configure all or type all this out. It took a little bit of time, so just save you guys the pain of watching me type all this out. It's very tedious, but it's definitely feels great whenever it's done. So let's get into this configuration, and it is now in. As simple as that. So as you guys know, an important thing to do after you make any changes on a device in a network is to verify your work. Always remember that. If you remember one thing, verification is huge. So, and it's going to save you a lot of troubleshooting in the long run as well. So make a change, verify. Just remember that one thing. So as you guys can see, we have access ports on all these interfaces. In order for us to check these interfaces, let's go to do show interface status. And this is a command you use on a layer 2 device to be able to see the status of the interface. And as you guys can see right here, we have E00, E01, E02. These are all on VLAN 10. E03, E10, E11, that's on VLAN 20. See? E12, E13, and E20 on VLAN 30. And I am missing one. Okay. So E21 and E22 are on VLAN 40. So I am missing one port. Actually, no. Okay. This port is up right here. Port, I don't know why I separated it out like that, but okay. I guess it's extending it. So I'm not missing one. I have E23 right here, which is this connection right here to and actually that's great too, because that goes into PC 12 right here. So PT 12 is on VLAN 40. So E23 on VLAN 40. So the access ports are configured correctly. And here's another way to verify your configurations for the access ports. It's the VLANs. So do show VLAN to be able to verify what ports went into the VLANs. And as you guys can see here, these ports are all changed from, you remember how they used to be on VLAN 1. They went from VLAN 1 to now VLAN 10 through 40. So we've configured everything correctly. So after we verify, let's save our work. And a good reason to save your work is if you have any, I guess, any shutdown or failover or situations where your devices go down. Whenever you reboot them up, the work will be saved. So always be sure to make your changes, verify the changes, and save the changes afterwards. Once you configured everything properly to your standard operating procedure or your method of procedures that your organization has stated for you. So now let's do RW. Remember to access privilege exec commands. You will use the do commands to be able to access those commands. So do RW is do WR is to save your work right here. So now let's exit. And from here, we want be able to communicate from communicate from VLANs to other VLANs. So now these are all logically separated into their own VLANs. Let's make that visual representation so you guys could better understand this. Okay. So you guys remember that PC 1, 2, and 3 are all on the same VLAN. So these will naturally be able to ping each other. So 192.168.1.3, which is PC2's IP, as you guys can see right here. PC2 is 192.168.1.3. So this one's able to ping PC2. Let's try PC3 to really drive home the point. So PC3 is 192.168.1.4. So let's copy that, ping. See, now we're able to ping PC 1, 2, and 3 are all able to communicate with each other. But now let's try PC4, which is in VLAN 20. As you guys can see, this is not able to ping PC4. So PC1's not able to communicate with PC4. And let's try PC7. PC7's in VLAN 30, so let's try that out. And as you can see, it's still not working. To exit is Control C. As you can see, you got 100% packet loss. So you weren't able, this PC was not able to communicate with the other PC at all. So let's try PC7. Same thing. Control C to skip this. We got 100% packet loss. So we weren't able to communicate with PC7 at all either. So now let's try PC10. Still not working. So as you guys can see, these PCs are now all separated into their own broadcast domains, or VLANs. So we utilized VLANs to separate this large broadcast domain into separate broadcast domains into their own individual networks, essentially. And as you guys learn later on, routers automatically separate broadcast domains by their interfaces. So router interfaces automatically separate their broadcast domains by default. In the switch environment, we utilize VLANs to logically separate broadcast domains. And one thing you got to understand, these are logically segmented. Physically, they're all ports that are just next to each other on the interface on the switch interfaces. So logically, these are all separated, and you don't necessarily have to group them together by how close they are on the ports or on the actual device. You could group them just logically. Say you wanted a port on this half of the switch, like ports 1, 2, and 3 to be grouped together with ports 20, 30, and 40 or whatever that's on the switch. You can logically group them together. They might be separated physically, but logically they're all grouped together in the same VLAN. That's the cool thing about VLANs and their ability to segment them out. So that is everything that you guys need to understand at I guess on a high level about VLANs. As you guys go through your CCNA studies, you'll get to understand the more nuances of broadcast and broadcast domains and even network segments. But this is essentially the gist of VLANs, and I hope you guys enjoyed the video. I hope this answered a lot of your questions and your curiosities, pertaining to VLANs. And like, comment, subscribe, and let me know what you guys want to see next. And